Hi everybody, welcome back to our exam review on Network Plus using Mike Meyer's book. Let me just make sure you're able to see it in case it's your first time joining us. My name is Executor and tonight we are going to be reviewing chapter 2. But before we go ahead and get started in chapter 2, let's just go do a quick review on chapter 1 just for those who are joining us the first time. So chapter 1, question 1 was where does a hub send data? And we said C, to all the systems connected to the hub. I'm just going to highlight it. And then question 2 was what uniquely identifies every NIC? Oh, by the way, I made a mistake defining a NIC. It stands for a network interface card, my bad. I said configuration, which is not quite. It's a network interface card. So what uniquely identifies every NIC? And that's the MAC address right here. Answer is B, the media access control address. And question 3 was, what Windows utility do you use to find the MAC address for a system? And we said that was A, ipconfig/all. Now 4, a MAC address is known as a blank address, and that was C, the physical address. Question 5, a NIC sends data in discrete chunks called blank, and we agreed that was frames, so C. Question 6, which MAC address begins a frame? And that's A, receiving system. Question 7, a frame ends with a special bit called the frame check sequence, or FCS. What does the FCS do? And we agreed that it verifies that data arrived correctly. So C was the correct answer. Now 8, which of the following is an example of a MAC address? And that was B, a 48-bit address. And I was saying you can always count these hexadecimal numbers 1, 2, 3, 4, 5, 6 times 8, that's 48. That's in contrast with an IP address, like D is an IP address which is referred to as a 32-bit address, because if we use the same technique, counting the hexadecimal, the decimals over here, so we have 1, 2, 3, 4 times 8, that's 32. So an IP address is 32-bit, and a MAC address is 48-bit addresses. Now, 9, which layer of the TCP IP model controls the segmentation and reassembly of data? And we agreed that was D, transport layer. 10, which layer of the OSI 7-layer model keeps track of a system's connections to send the right response to the right computer? And we agreed that was session layer. Session, connection, they go together most of the time. Now, chapter 2 review. So I'm assuming a lot of you are ready to take your exams, or you have done the reading in these chapters and you just want to review it. That's why I don't go in depth in these chapters. So, but for this specific chapter, I have prepared some graphics for you to just help you understand a lot of the terms over here, so we can just fast forward through this one. And as you can see, if this is your first time, if you're a beginner and you're actually studying to go for the Network Plus exam, so that means terms like the star topology, bus topology, mesh, and ring topology might sound new to you. So that's why this we just couldn't go over quickly and say which one was the right answer, and I just have this here to help you, help clarify a lot of these terminology here. So over here, the first one is going to be the star topology. This is how a star topology looks like. Let me just make sure it's you're able to see it. So this is a star topology, and you have a router or a switch or you have a switch or a hub in the middle, and every other node connects to it, forming a star, and that's why it's called the star topology. And then the next topology is going to be the bus topology right here. Now the bus topology, as you can see, it's very simple, just a straight wire and every other node is connected to it. So that's the bus topology. And the ring topology is next. So this is the ring topology, and as you can see, every node is connected to a ring and they all share the signal through the cable. And next is the mesh topology. The mesh topology, as you can see, every other node is interconnected with each other, forming a really good redundancy, so fault tolerance to say, which you'll be learning more about. So this is the mesh topology. Make sure that you guys can see it. And then the star ring topology. So these are what are called hybrid topologies. That means the combination of one or two or more topologies. So, and this is the star ring topology because you use the star topology and the star topology and the ring topology. And next we have the Starburst topology. And as you can see, we still have that same wire and the star connector is over here. And that's why this hybrid method is called the Starburst topology. Now, I also have a few standard connectors here that I would like to show you guys. And this is definitely, you know, well known by everyone. It's widely used, and it's called the RJ45 connector. The standard RJ45. It's used with unshielded twisted pairs. So unshielded and shielded twisted pairs. It's an 8-wire pair. 8-wire pairs that use this connector, this standard connector called the RJ45. RJ45. And next we have 3 types of coaxial cables, and they use different connectors. This connector is called the Bnc connector. The Bnc, I mean, it's mostly defined as bayonet Neil Conselman. Bnc stands for bayonet Neil Conselman, and that's what, you know, most experts have defined it as. And it's supposed to be the last names of the inventors of this connector, and it's used by the RG58. RG, by the way, stands for radio rating, radio grade. And the 58, the version 58 is an old one and it's not widely used anymore. And next is the F-type connector. This is the F-type connector, and this is used by the 59 and 6, the RG59 and RG6. They use the F-type connector right here. Next, so we have 4 types of fiber optic cable connectors, and 3 of them are non-duplex. The 3 that are non-duplex are the SC connector, these ones. The FC, this one. By the way, SC stands for standard connector. FC stands for fiber channel or fiber connector. Depending on the authors, different people call them differently, but yeah. Fiber channel or fiber connector and standard connector. And the ST connector and the LC connector. So as you can see, the ST connector and the FC connectors are very alike, like they look alike. The only difference is that this ST, the ST, which by the way stands for straight tip. ST stands for straight tip. So this uses a locking mechanism, and that's what makes it different. And they both are used for high vibration environments. And yes, they're currently fading away because of these two. They're very expensive for companies to manufacture them, and the most standard one is the SC connector. It's widely used because it's affordable and efficient. Now, the LC connector, which stands for local connector, is used for duplex mode. You will be learning a lot about duplex mode. If you have done the reading on the chapters, I'm sure you have already come across all these terms. So this is supposed to just be a refresher for these terminology and connectors. And then we also have the barrel connectors. Barrel connectors are also used by certain types of fiber optic cables. Sorry, not fiber optic cables, coaxial cables. Coaxial cables. So, and that will be it for the standard connectors. I suggest you do your reading, do your research. There is a lot more out there, but these are just the standard ones that that Comptia really worries about. So this is the one that these are the ones that you might come across during your exam, and that's why you really need to know them. But there are tons and tons. So now we can go back to chapter 2 review. And question 1 was saying, which of the following topologies required termination? And if you remember, the topology that you think might require termination is this one, the bus topology. A bus topology. So the bus topology requires termination on these ends. If you don't put a T type of terminator in there to stop signal, then you'll be losing signal. Like all these nodes attached to the topology will be losing signal because of that. So that's why it requires termination at each end. So the correct answer will be bus topology. I'm just gonna go ahead and highlight that, make sure that you guys are able to see that. Question number 2. Starbus is an example of a blank topology. Starbus. So as I was saying, Starbus, yes, this is a star ring, but a Starbus is right here, and it's part of the hybrid topologies. Hybrid topology. So Starbus is an example of a hybrid topology. So the correct answer will be C. And next is 3. Of the topologies listed, which one is the most fault tolerant? Most fault tolerant. So if we go back, I was mentioning, so see the way the star topology is connected. Let's say the connection from this node, make sure that you guys can see that. Yes, from this node to the hub or switch breaks, then all the other nodes connected to it are still working very well. They still have signal. So they still have signal. That's just an example to explain to you why the star topology is seen as the most fault tolerant compared to all the other ones listed here, of course. So let's move on. Number 4. Number 4, yep, make sure you guys can see that. What term is used to describe the interconnectivity of a network component? And that would be, so segmentation is wrong, because segmentation is when you divide networks into sub-networks, smaller networks. And the map is just a physical or logical placement of things, of your items in a network. And protocol is definitely not it, because protocol is a standard. A protocol is a standard, and that leaves topology. So the term used to describe the interconnectivity of a network component is C, topology. Now 5. Coaxial cables have a blank rating. So resistance, we know it's not resistance, because resistance is a measure of the opposition of current flow in an electrical circuit. So it can be our answer here. So this one is not correct. Now a watt is a unit of electrical power equal to an ampere. under the pressure of 1 volt. So the watt is definitely not A. The unit of measurement of electrical power is not A. And speed, as we all know, is a rate at which an object is moving. So speed is definitely not A. And now that leaves this guy, the culprit, ohm. Because an ohm is a unit of measurement of resistance, of electrical resistance of a wire. And that's why that's the right answer. So ohm is the right answer. And oh, by the way, remember when we talked about the standard connectors, and I was showing you yes, these 3 types of coaxial cables that we discussed. So the RG58, this one, the RG58 has 50 ohms, and the RG59 and RG6 have 75 ohms. So when you get to the exam and you see that question, you have to remember RG59 and RG6 have 75 ohms, are rated at 75 ohms, and the old one, the old version, RG58, are rated at 50 ohms. Okay, let's move on. 6. Which of the following is a type of coaxial cable? So RJ45, we already know, is a connector for the shielded and unshielded twisted pair. So that's not a coaxial cable. Now, a Bnc was a connector used for coaxial cables. So it's not a cable, it's a connector. The bayonet Neil Conselman, remember when I mentioned that? And the barrel is also a type of connector, which I right here, the barrel. Let's just go back to make sure that it's understood. Right here, the barrel connectors, which are almost, called fiber optic connectors, which is coaxial cable connectors. Right here, the barrel connectors. So they're not fiber optic cables. Now that leaves the right answer will be RG59. We have 3 types of coaxial cables: RG59, RG58, and RG6. Now moving on. 7. Which network topology connected nodes with a ring of cable? So as already discussed, that will be the ring topology. 8. Which network topology is most commonly seen only in wireless networks? So that will be the mesh topology. This is our first time mentioning the mesh topology. And let's just go back really quickly so you can see how the mesh topology looks like. This is the one mostly used for wireless networks. Mesh topology. So number 9, which of the following is a duplex fiber optic connection? Duplex. You have to pay attention to the word duplex. And when I was showing you guys the standard connectors here, I mentioned it already. Yes, over here. I was telling you these 2, the ST and the FC, are pretty old, phasing out. Not that common anymore. And the SC is the standard connector, widely used because it's cheap, affordable, and somewhat efficient. And that left the LC, which is looking special, by the way. I have that over here. This is it. And the LC connector is LC right here. So when you get to the exam and you see this question, you have to remember the LC. The LC is the one that is a duplex fiber optic connection. Next, number 10. What is the most common category of UTP? By the way, UTP, unshielded twisted pair. So what is the most common category of UTP used in new cabling installation. If you've done your reading, you probably guess. Definitely not Cat 3 because it's way too old. Don't even know if it's used anymore. 5E, somewhat common, but performance-wise, not so good. Now, Cat 6. Cat 6 is the one. Cat 6 is the one. And Cat 7 is still brand new and currently catching up with Cat 6, but Cat 6 is still the one that is, you know, the most widely used in new cabling installations. And yep, now chapter 3, that will be it. Oh, by the way, everybody, I would like you to know, please do your readings, keep doing your readings and your research. If you want complete videos that go in depth, you know, about Network Plus, you have Mike Myers videos and you have Professor Mayer's videos. You have all these really great videos that go in depth. Like they pretty much go over every single thing that is written in this book. So do your readings, do your research, and please understand that we're only here for review of these chapters. That's why I don't go into every single details. And I hope this is, I hope you guys find it helpful. I hope this serves as a refresher after you do your readings of a chapter, and you know, and come and we discuss these, and hopefully it helps you absorb that information until exam day. So please keep doing your readings and leave some comments on how I can improve these tutorials to help you you know, pass your exam. Thank you very much, everybody, and I will see you guys next time for chapter 3. Yep, next time for chapter 3. Bye.